PhD proposal presentation, Doctor of Engineering degree in Electrical Engineering by Frank Ullom on the topic Optimal Operation and Control System for Hybrid Gas Turbine Power Generation in Ghana. In this presentation, I will be presenting on abstracts, introduction, literature review, methodology, optimization concepts, and conclusion. In the abstract, what it entails. Thermal generation of electrical energy is becoming the global solution in the recent time and coupled with carbon emission. However, operation and maintenance of it is a big challenge to consumers. In order to reduce these challenges associated with a hybrid gas turbine, it is important to develop a resilient control system that provide optimal control method to manage the fuel properties such as parameter variations, ensure cost-effective performance operation as well. What does the thesis entail? What am I going to do? I'm going to design, implement an optimal operation and control system for the hybrid gas turbine power generation system. In order to increase the efficiency and performance of a hybrid gas turbine or gas turbine generation system in general, it is necessary to have a stable controller design, or the type of controller used determine the performance and stability of the plant. The controller design must be able to handle dual nozzle operation system if the generator is meant for dual nozzle control, and also be in position to ensure smooth transition from one primary input to the other. In view of that, I've classified the type of controller system which is supposed to do such capable work as advanced control system, and classify advanced control system to have some basic features such as intelligence and sensor applications, which will provide reliable data for efficient operation. Optimization and scheduling for the purpose of monitoring and to ensure that the cost-effective set points are being used for the scheduling purposes. And above all, must be able to ensure management information system, which will bring together all the components within the system, the information that they are carrying, and manage the information for the purpose of control decision making. What problems is the thesis seek to address? 1. To provide smooth transition between two fuel sources such as gas and natural crude oil. 2. Address the problem associated with plant failure to start after maintenance. During maintenance of a gas turbine, because of wear and tears or because of the rotating parts, most components are meant to be changed at the shutdown state. This component indeed has their own characteristic which affect the control loop system and require regular tuning in order for the control system to be stable. So indeed, regularly after maintenance, the control tuning is required. And if you have a maintenance team that hasn't got the tuning capability, the plants tend to suffer and the cost of maintenance becomes very expensive. So what is the aim and objective of the research? Basically, the aim of the research is to provide best performance operation and control of the hybrid gas turbine power generation in Ghana as well as the third world country, and also to encourage the use of dual fuel system for cost-effective management of the power generation. In undertaking this topic, in choosing this topic, it is important to do a literature review in order to be certified that the problem identified and wanted to address has not been addressed by other researchers. So a number of literatures were reviewed along the line of the problem and realized that although researchers have made the effort to resolve the problem to some extent, they have not been able to successfully address the smooth transition between the two fuel systems and develop a system where cost also become a determining factor of which fuel system to be adapted at a time. So that enabled me to do plant-wide review of the control system for the dual fuel system, looking at it from the block diagram point of view here. The existing system has a dual system control by the control action is by electronic control system. My focus will be mainly on the electronic control system, where I'll be using the electronic controller to reprogram it to be able to operate within a certain set point by ensuring that the smooth transition of the fuel from one fuel level to another is being successfully achieved, and also the cost of it. So I'm going to operate it optimized along the side of cost and availability. So the electronic controller will be redesigned to say that when liquid fuel is available, the system will use. When gas fuel is available, the system will use. However, the system is also using the cost of these systems to determine which fuel source should be used at the time, if both is available or if both are available. The method to use to come out with the whole of this are as follows. I'll do a comprehensive review of the gas turbine plants and its control system, look at the fuel system and their control, understand the principle behind the dual nozzle and the control system, and review the mechanical and thermal aspect of the entire engine. Move ahead to look at the alternator system for electrical power production and do dynamic analysis and design of the dual nozzle control system using the PID controller parameterization for the dual nozzle control system. The dynamic approach of the project is we have two sources of supply to the dual nozzle, which the dual nozzle will be designed to allow only one source at a time depending on the availability, and that will be sent to the combustion chamber to mix with the compressed air, which will be pressurized at a high temperature, and that will work on the turbine brakes, thereby turning the alternator shaft to be able to produce the electrical output. All these systems will have to be synchronized and optimized at a particular point so that there is a complete information flow from the power demand to the supply of the primary input sources. After which MPC controller design will be made for the dual nozzle system that will use to shade the PID, and the design will be dynamically modeled and simulated in MATLAB, and the results will finally be analyzed, discussed to see whether it has actually met the purpose or the objective of the work. The optimization is a key aspect of the work that has to be done. So in doing that, I formulate a process to be used for optimization. That is one, define the problem which already I have seen, make numerous assumptions on the problem, formulate mathematical problem, solve the mathematical problem, interpret the results and solution, put that into the model, verify the model. If the model is right, work perfectly, I'll develop a report and predict the outcome. If I'm unable to solve the mathematical formulation that I have, I will relook at the assumption that I made to see whether I'll be able to get the results. And this is the process I intend to use. This is the process I intend to use. In summary, I developed a conceptual block diagram for the whole project, and in a conceptual block diagram, I have PID in the respective loops and MPC controller providing the most effective set point for the PID and shading the PID so that the PID parameters are not disturbed. The MPC function here is to be able to use the present and the past state to predict the future response that will be fed to the PIDs. It also has the dual nozzle system, which allow only one source at a time, and that goes to the combustion chamber, mix out with the compressed air, work on the turbine brakes to rotate the alternator shaft for power generation. In conclusion, the system will have to realize smooth transition from one fuel source to another, eliminate problems associated with plant operation, address tuning problem, and MPC controller to be designed for protecting the PID controllers, and simulate the system to ensure that it's being able to handle constraint as objected by the system. Thank you.